in this video, we want to learn about the design generators. In fact, we want to see that, okay, so when we say, for example, we said that we would say D is equal to ABC. Or here you can see we said that C is equal to AB. So we are, in fact, we are designing a generator. It's like that. We are generating our designs, right? The fractional ones. So in this video, we want to learn about it. How can we do that? Let me show you my note. So when, for the design generators, when we say D is equal to ABC, we found that AB was equal to CD, AC was equal to BD, and AD was equal to BC, like their effects, they were the same. By comparing columns of the positive and negatives. It is possible to determine the confounding, aliasing, or masking more directly using the concept of the defining relation. So here we need to understand what's the defining relation. How can we have the defining relation? To obtain the defining relation, we have 3 steps. The first is that start with the design generator of, like, for example, D equal to ABC. And then multiply both sides by D. So you would have D power 2 is equal to ABCD. Then set square terms to I. So we would say that instead of D power 2, we would say it's equal to I is equal to ABCD, where I is a column of plus signs. And we would say that is identity column. Because whatever the sign is, you would power, when you square it, it's going to be a plus sign, right? So we call I as the identity column. So whenever you saw the column I, it would be your identity column. And so here, in this way, we can find out the, like we would obtain the defining relation. So we would say I is equal to ABCD. This is our defining relation. To determine which terms are confounded, so after this is going to be very easy. So when we have the defining relation as ABCD, we would multiply defining relation by terms of the interest. For example, you want to see that interaction of AB, what are the confounding terms with this AB? So you would say AB times I is the positive sign, right? So and here we define our defined relation was ABCD. So AB defined multiplied by ABCD. So it's going to be A power 2, B power, like it's like A times A squared, B times C, B squared, and then CD. So you can say that instead of A squared and B squared, you can write down I or 1, and then you would have CD. So I would say AB is confounded by CD. So you can here set the square terms to I, the identity column, so AB is equal to CD. The whole set of confounded groups is found by multiplying the defining relation by all main effects and the interactions that we would have. Let's do some examples. So we want to find out the confounding pattern, like for example, for A, B, C, A, C, and B. You can pause the video and work on by yourself, and then come back and check your results with ours. So what we said that with the steps, what are we gonna do is that we would say that the first thing is that we're gonna write down our design generator. So the design generator, for example, D is equal to ABC. This is the highest order of the interaction that we would have. So this is the design generator. And then what are we going to do for finding out the I as a defining relation? So we would say that we are going to multiply both sides with D, because we want to have D squared, and D squared is equal to, it's going to be positive sign, so it's going to be I. So what are we going to do? We would multiply both sides by D, and then we would say our defining relation, it would be equal to A, B, C, and D. The defining relation is like that. We can show it by I as well. So I can write down for defining relation, I is equal to A, B, C, and D. Then when we want to find out the confounding pattern, like we want to see that A is confounded with what? What are we going to do? What are we going to do is that it's like we can say I can write down A times I, right? I is just the positive sign. So I would say instead of I would write down my A, B, C, D. So it would be A times A, B, C, D. So it would be A squared, right? B, C, D. So here I'm gonna have like B, C, D. This one is like just, I don't consider it like that. It's gonna be equal to I. It's A squared. And then we can do that for the rest of it, like for example, for BC, multiply BC by AB. ABCD. So it would be A and B power 2, C power 2, and D. So it's going to be AD, right? This one is this is one, so it's going to be AD. What are we going to say is like that here we would say A is confounded with BCD. Or here you would say that, like, it's very important when you think about it, your A is the one factor. So it's confounded with the BCD, which is the 3-factor interactions. Definitely this one is better, right? When you think about it. This is like you consider the interaction of the 3 factors. And then BC and AD, we can do that for AC as well. So is that AC times ABCD. So it would be A to B and then C to D. So it's going to be BD. And then the last one is B. So it's B times AB CD. So it would be A, B2, CD. It's going to be AC. So with this method, we can find out all of the interactions, compounded interactions that we would have for any of these ones, anything that you're interested. Maybe you would be interested in, like, let's say BC. No, BC we have it. Like, let's say something else. You wanted to know that, okay, instead of ABC as a third order interaction, what could you use? So quickly you will find it here. Any interaction, you can find it like this. Or the confounding pattern, you can find it like this. So now let's share the screen. Let's go back to our notes to see that. Where are we? Okay, so we worked on this one and we had an example. So let's look at here. And the previous half fraction of the 2 power 4 design, like with 4 factors, can be extended to a 1/4 fraction of the 2/5 design by adding another factor to the base design. So let's say we want to study 5 factors, in fact, in 8 rounds. So what we're going to do is that we would say, let's say, for design generators, we would say D is equal to ABC and E is equal to BC. And then we just multiply that, and then you would have all of these signs. So E equal to BC is like that. Negative is going to give you positive. Negative is going to give you negative. So you would just multiply, and then you write down your treatment combination based on A, B, C, D, and E, because you said that we have 5 factors. So what are we learning here is that you can pause the video and think about it a little. So what's the main difference between this one and the previous one? So here we are, in the previous one, we were working with the half of the fraction, like half fraction. But here we are talking about the 1/4 fraction. It's like that. We want to see that what's going to happen when we have 1/4 of the fraction. Think about it this way, and then think about the look at the design generators that we have. You can pause the video, think about it, and come back. So what do we have? I think we have a question here. Yeah. How could you get the other 3/4 fractions of the full designs? So this is because we said we have quarters, so it's like 1/4. So we have 4 designs. So this is the main one, the principal one. D is equal to ABC, so and E equal to BC. So what do we have here is that with the design generators, we would have D is equal to plus minus ABC, right? And E is equal to plus minus BC. So we have 2 different design generators that we would need to use it at the same time. And then we are going to get the combination of those when you want to find out the other like 3/4 factors of the full design. So if you want to write down on the board, it would be, so it would be, we said that the current one, we had 5 factors, right? And we said that, so we would say D is equal to plus minus ABC, and also E is equal to plus minus BC. Later we are gonna, each time I write it down like a little higher. Okay. Like this. Okay. So D is plus minus ABC. And when we are working in we have a table. So in the next video, you're going to see the table. So we would have a table with the number of factors and runs, and these design generators, the table is going to give it to us. So we'll learn it. So now let's just focus on that and the concept of it to understand it. So, okay, now I have this one. So the main one, like the principal one, the principal fraction here. So I would say D is equal to ABC and E is equal to BC. Then the 3 other fractions that I'm looking for is that I'm just going to mix and match them. So I would say, for example, one is going to be D is equal to ABC, and then E is equal to minus BC, right? And then I would have D equal to minus ABC, and E is equal to BC. The next one is going to be when both of them are negative. So it's E is equal to minus ABC, and then E is equal to minus BC. So here I would have like this, my main, the first one, second, third, and fourth. So I would have like when we say 4, like 4 fractions that we have. So these are going to be our 4 fractions. This is the main one, and these are like the principal one, and these are the alternate designs that we would have. So let's go back to the slides. So we want to find out the confounding pattern, also referred to as alias structure. So for we would say the same rule that we had before, like D is equal to ABC, and we're going to multiply both sides by D, so I is equal to ABCD, and then we have E is equal to BC, so I is equal, it's going to be, we are going to multiply both sides by E, so I, our defining relation is going to be BCE, because we said that for finding out the confounding pattern, first we need to write down the design generator, then we need to find out the like defining relation, and then we would multiply it, right? So for the defining relation, so we would say I is equal to ABCD and E is equal to BC and E. Based on the design generators, we are going to find out these 2. And then ABCD and BCE are often referred to as, we would call them words. So this is the first one and the second one. The defining relation includes all words that are equal to the ABCD and BCE. And in fact, you can think this way. You see these letters? What we want to do here is that we want to, instead of saying this like the combination of the letters, we just say words. And then all other words that can be obtained by multiplying these generators, we would say that these are the defining relation. So what happens is that when we have like A, B, C, D, because A, B, C, D is equal to I and B, C, E is equal to I as well. So if I multiply them, so I'm gonna have again I. So I is equal to A, B, C, D times B, C, E. And when you multiply it, it's gonna be A, D, E. So whenever we have more than one design generator, when we want to find out the defining relation, we need to multiply the whatever initial defining relation that we would get. So the defining relation is then given by, look at here, A, B, C, D that we found here, B, C, E that we found here, and A, D, E, which is the multiplication of these two. So now what is the confounded with the AB interaction in